For do now number 3, if G is the circumcenter, we want to find X. And again, if G is the circumcenter is equidistant from the vertices of the triangle, which means this piece, and this piece are all congruent. The only two that I care about in this case are this one and this one. So if AG is 7x minus 41 and GC is 5x minus 19, those two things have to be equal to each other. So we'll set 7x minus 41 equal to 5x minus 19, and then we'll solve. Subtract 5x from both sides. 2x minus 41 is going to equal negative 19. Add 41 to both sides. And when you do that, you'll be left with 2x is going to equal 22. Divide both sides by 2, and x is going to equal 11. A question only asked you to find x. You found it. You're done. For number 2, the point of concurrency of the angle bisectors is called the incenter, and it is equidistant from the sides of the triangle. So today we're going to talk about section 4.4, which is about medians and altitudes. And the median is a line drawn from the vertex of a triangle to the midpoint of the opposite side. So again, you can see in that picture that the median of that blue triangle is that red line. Again, this piece is going to be equal to this piece, and that would be its midpoint. Okay, so a centroid is the point of concurrency of the medians of the triangle. So again, if you draw all three medians and then the point where they intersect, in this case would be P, and P is what's called your centroid. Okay, and the thing that's special about your centroid is that it divides each median into the ratio of 2 to 1. So again, with relation to this picture that you're looking at here, the ratio of AP to PL, the ratio of here to here is going to be 2 to 1. The ratio of BP to PM is 2 to 1. Okay, so again, the longer side is going to be twice as long as the shorter side. And from CP to CN, okay, again, CP is going to be 2 times as long as PN. Okay. And again, you can see that no matter how I drag this point, again, anywhere I go, what happens to that centroid? It is going to stay on the inside of that triangle. Okay, so the centroid must always lie inside the triangle. Okay, so in the diagram, PV is going to be 8, and we want to find the length of PT. So PV is this piece right here. That's 8, and we want to find the length again of the entire segment PT. So again, PV is going to be twice as long as VT. So the first thing that I'm going to do is I'm going to figure out if I take that 8 and divide it by 4. I'm sorry, if I take the 8 and divide it by 2, I'm going to get 4. So this piece over here is going to be 4. So all together, it's going to be 12. So again, if it's in the ratio of 2 to 1, it's twice as long. That's why I divided it by 2. And again, 2 times 4 would give you back that 8. So that's always going to work that way. So now if QU is 54, so all 3 pieces that make up that line, again, if they're in the ratio of 2 to 1, it's a total of 3 pieces that make up that line. So all 3 pieces of that line are 54. We want to know the length of QV. So let's find out what one part of that line would be by taking that 54 and dividing it by 3. When you take 54 and divide it by 3, you're going to get an answer of 18. Okay, which means again that this smaller part, VU, if that's the piece that's represented by one of those segments, one of those pieces, that would be 18, and QV is going to be twice that. So twice that would be 2 times 18, which is going to be 36. So 36 is the length of QV. For number 3, if G is the centroid of triangle ABC and BF is 72 and AC is 64 and GE is 25, we want to find each missing measure. So the first thing that we need to find is AF, which is this piece here. So I'm going to go back and I'm going to write some things in here. So BF was 72. So that's 72. AC is 64 and GE is 27. Okay, so again, if I want to find the length of AF, if the entire length of AC is 64, remember F is the midpoint there, which means that AF is going to be half of that 64. So 64 divided by 2 will give me an answer of 32. So this piece is 32 now, and this piece is 32. FC, I just found that. That's 32. Okay, and the next thing that we want to find is BG. Okay, so BG is part of this median right here. And again, if the entire median is 72 units long, and again, we want to know what 1 unit is, and there's 3 units all together, each unit that makes up that median is going to be 24. Okay, and again, if I want the longer piece of that median, again, that is going to be 2 times that 24. So 2 times 24 is 48. Then for GF, that's this little piece right here. And again, that makes up 1 unit of that line, which we just found over here. That's going to be 24. So GF is 24. AG is going to be represented, let me change color. So my pen here is going to be represented right here. So that's AG. Okay, and AG, if GE is 27, 27 represents 1 unit of that median, and AG is going to be 2 of those units. So that's going to be 27 times 2, which will be 54. And then for AE is that entire purple segment that I just highlighted. So if I take my 54 and add 27 to it, I'm going to get an answer of 81. Okay, an altitude is a line drawn from the vertex of a triangle and it's perpendicular to the side opposite. So again, perpendicular is going to mean that it intersects to form a right angle. So in this red triangle below, that blue line is the altitude. Okay, and just like all the other stuff that we've been talking about inside of this chapter, we're going to draw 3 of those. So if I draw all 3 altitudes of your triangle, the point of concurrency is going to be called the orthocenter. Okay, so the orthocenter in this picture over on the right is this point O right here. So O is that orthocenter. Okay, and again, let's see where it's going to be located. You can see on the bottom here, it's going to be inside. It can be outside or it can be on, but let's go into this. And there again, you saw it move, but right now it's on the inside of that triangle. And if I take that and drag it, there it is on the outside, and there it is on. And notice when it's on it, that's a right triangle. So again, it could be inside, it could be on, or it can be outside. So again, if it's inside, you can have a triangle that looks like the one on the left. If it's outside, it's going to be this middle one. So inside, it's acute. Outside, it's going to be an obtuse triangle. And if it's on, it's going to be a right triangle. Okay, for the triangle ABC, is each segment a median, an altitude, or neither? So again, if it's a median, that again means that it's going to intercept at its midpoint. And if it's an altitude, it's going to be perpendicular. So let's look at AD first. So AD is this line right here. And again, when I look, I have this piece is equal to this piece, which means that D is that midpoint, which means that this one is a median. For EG, EG is this line segment right here. And without being told anything else, you cannot assume that that is going to be a right angle on this side over here. I don't want to really draw it. You can't assume that that's a right angle because you were not told. So you can't assume that that's a right angle. Okay. However, okay, and it's also not a median. Why isn't a median? Even though this is congruent to this, again, a median has to be drawn from the vertex of the opposite side. So if I wanted the median that was going over to this side AC, it would have to be B that connected to that midpoint right there. So BE would be the median, but EG is not a median. So this one is going to be neither. Clean this up just a little bit if I can. Okay, and then my last piece here, I got a lighter blue. I want to know what CF is. And there's CF. And that little box right there, again, means that that's perpendicular. And which is going to be perpendicular, the median or the altitude? It's going to be the altitude.